Hey everyone, we're in Huizhou, China, looking at one of Cooler Master's testing facilities. So we've already seen some other stuff. I don't know if it's on the channel yet, but what we're looking at today, there are two aspects I really want to address here. One of them is basically all cooler reviews are flawed, and this is something that we talk about in our cooler reviews. They're flawed to an extent. We'll go over why here. This equipment more or less demonstrates it. And then also TDP. We'll be talking a bit about both of those subjects. Before that, this video is brought to you by the Gigabyte RTX 2070 Gaming OC, now available in a matte white model to match the emergence of white PC cases. The RTX 2070 Gaming OC uses a 3-fan cooling solution and 4 composite heat pipes on NVIDIA's newest Turing GPU, and ships with a pre-overclock of 1740 MHz in OC mode or 1725 in gaming mode. RGB fusion is also available for the LED enthusiast. Learn more at the link in the description below. I guess we'll start with this. Right now there's a Hyper 212 hooked up behind me here. So this is set up, and what this chamber is doing is pulling in air through the bottom. So there's actually a giant blower fan here. And the goal of this test, I'll walk through more of the specifics in a second, is to look at the thermal performance. So it's not a obviously perfectly real world scenario. So you're not getting the real world performance that would be affected by, for example, the TIM between the IHS and the die. So that's not accounted for here. But the point of doing something like this, which is the same reason we do sort of really controlled tests in our own lab, is so that you can get consistent numbers where you can compare one device to the next. So if Cooler Master works on another product, maybe following the 212, then they have some data they can compare to from previously. So there's ups and downs to it. There's some real world testing we'll show too. But the way this works is looking at some of the thermal numbers that are on the screen here from a previous test run. You can see that ambient temperature is here. It's hooked up to a K-type thermocouple we'll show momentarily. So ambient temperature, you have the operating temperature of the hot plate. There's a thermocouple sandwiched between the hot plate and the cold plate of the cooler. And there's actually a milled out hole for that thermocouple to go into, which is another thing we've talked about in the past. Intel's TDPs do similar things to this, but it allows you to get some more direct temperature readings. So there's no CPU required here, which is actually really good because, and this is why cooler reviews are often pretty flawed, because once you introduce a motherboard and a CPU, you're introducing potentially dozens of different voltages, most of them on auto because people don't really control properly, and that changes the performance every time. So every time you boot cycle, if there's a reset somewhere in BIOS, then it could change the voltages to really small points, fractions of a volt, which will impact the results. But also, there's impact from things like, for example, paste application or whatever. But anyway, so this machine, we have the readout is 51.35 for the current test, the Hyper 212, and all the different readings here, and we can show this more in B-roll, but all the readings here give things like the temperature of, I think we have ambient, I think we have water temperature or something like that. So there's actually a tank here that's used for controlling humidity levels. And this is a water tank, and it's hooked up so that the humidity inside of the chamber can be more or less simulated to the humidity inside of a room that might be under target testing, depending on what kind of humidity Cooler Master wants to test for. But so that can be controlled. And also another reason that cooler reviews can be flawed, because we don't have any control over this without a thermal chamber. So there's only so much you can do in a review to where you get down to maybe a 3-degree difference. And at the end of the day, a 3-degree difference could be paste application, it could be torque on the socket, it could be humidity, it could be ambient temperature. So all these things are why, if you're really making the product, you need real testing equipment like this. And the way this works is, like I said, there's a blower fan on the bottom. It pulls the air in, and the air enters in on this side of this particular chamber, comes through, goes through some flow straighteners, which are just big mesh wires sort of in the middle of the chamber. We have some of this at home too for our own airflow testing. So it goes through flow straighteners, which make sure that the air doesn't diffuse and just go all over the chamber. And as it goes through the flow straighteners, it eventually gets through all the way over here. And as you can see, there are a couple of pressure sensors hooked up, and these are tracked via software as well. So pressure sensors give us the air pressure. You could get CFM if you're testing a fan, for example. There's another test setup with that. So you get cubic feet per minute airflow, and that's calculated because you have a known volume, so you need a known volume of the chamber to get that. And the air comes out here, and we can do the thermal test, or on the other side, if we show it, you can do the airflow testing with the fans. Then moving on to this side, So this is where the air is actually coming out, and it's a bit warm here because it's going through, like I said, there's a hot plate on the bottom. And this is ultimately, if we really in-house wanted to do as perfect thermal testing on coolers as we could, you'd have to do something like this. The problem is that for us, we start deviating so much from real world that in a review for a consumer, it's not quite as useful because as a consumer, you're dealing with, again, things like the IHS, or the thermal interface between the IHS and the die. And so even though this cooler might be doing 51 degrees here, the Hyper 212, this is 200 watts in the hot plate for the earlier testing. Even though it's doing 51 degrees for the K-type that's sandwiched between the cold plate and the hot plate, in reality with the CPU, that number could be much higher, and it's going to vary depending on the CPU as well, and how well the die contacts the IHS, contacts the thermal interface, contacts the cold plate. So it gets really complicated, and that's why the real world tests that we do are, of course, to some degree flawed, as all review tests are, but as long as you know the flaws and you, of course, talk about them and educate the audience, it's fine. It's just that we wanted to show this side of things where it's a more perfectly controlled scenario so that you can get some really good comparative numbers and data, and then you just extrapolate to real world as best you can, or you do real world testing. We'll look at that in a moment. So then finally, over here, there's two K-types hooked up, and one's where I already said it is there. The second one's over here for ambient temperature, so you can get the temperature going into the cooler, and then the temperature of the hot plate, and figure out how well it cools. So moving on, we talked about real world a bit, and this setup over here is representative of that. So it doesn't look like much, but as I said, you want to eliminate motherboards where possible. And Intel, for years now, we've talked about their TTV, or their thermal test vehicle. We showed one of these in Corsair's lab previously as well. So it's a thermal test vehicle that Intel provides, and you can use it for cooler testing. It's extremely controlled. They also have some custom software they build for other types of testing. This is AMD's. So quick note, the thermal paste around the CPU is just because it's been used a lot, but that's not how it's actually supposed to be. But that's how ours looks too, so it's fine. So this is the AMD thermal test vehicle. There's a thermal probe up here, probably just for ambient. You can move it around if you needed to change for the height of the cooler, and you can see that there's just adjustment here, so if you wanted to change the height of that screw holding the probe in place, then that could be done. K-types are hooked up back there, so that's more thermal probes. You could take, I think actually there's a thermal probe directly mounted to the top of the AMD Ryzen CPU there, or the fake Ryzen CPU anyway, the thermal test CPU. And then up here is the benchtop power supplies. These are used to control the wattage. So if you wanted to set a specific amount of power going through the CPU, you could figure that out through just doing volts times amps gives you watts. So that's the more real world stuff. This would be used for sort of validating performance for customers, the people buying the coolers. It's no secret, Cooler Master makes the AMD coolers, so that's why you see this here. And then there's another test vehicle over here. So this is pretty cool as well. This is similar in some ways to the one that we showed first, where it is pushing air through a cooler and testing the cooler. So you can test for things like flow impedance caused by the fins. That's a really important point, where as fins get denser on a cooler, you potentially encounter the issue of the airflow getting impeded to a point where there's diminishing return. So ideally you have the density, you have the surface area without creating impedance, which could create things like turbulence, noise, and actually worsen performance. So this is able to test for that. There's a cooler in there, we'll show in B-roll, and air is just pushed through it. And this is more or less to accommodate different size coolers. So you can work with lower profile stuff if you're working with like a longer cooler, as this one is, or something with where the height isn't as much of a concern as it is with the other test chamber. So this is the last part of the lab we'll be talking about. This is the same machine, just mirrored from over there, but it's set up for different testing. So instead of a cooler mounted to it, it's got a fan mounted to it. And I guess I'll note a few things here. Number one, this is Windows XP. Number two, this machine is $75,000. So you can put those two together yourself. So Windows XP, obviously, very reliable. If you've already got your software set up, why change it? And so this machine is set up, instead of using a blower fan to push the air through and funnel it through a cooler on the other side, like was being done over there, where the air is getting pushed through, generated by a fan within the system, and then piped in through a hose at the front. Instead of that, they're mounting a fan to the front so it can be tested. And if you're kind of looking at the fan going, well, that's sort of small compared to the volume of the chamber, the way the air is guided through is there's actually another blower fan down here which we have shots of too, and that one is working in inverse from the fan at the front. So this fan at the front might be set to something like 57.3, 53.7, whatever it is on the box for the CFM, and then the fan down here will mirror that and be set to the same thing so that it doesn't impact the result, but it does guide the air through the system so that you can get the pressure measurements as needed, or the flow measurements. And then the voltage can be varied, so they can test across different points of the curve, voltage curve or PWM curve, to get the performance at, say, 30% RPM, or 30% RPM or 50% PWM signal, whatever it may be. And additionally, the software can aid in generating a PQ graph if you wanted something like that. So this is more or less the Cooler Master cooling test lab we wanted to show off. For air coolers, you could use it for liquid coolers, but mostly for fans here, we have an air cooler mounted back there, and then the real world testing as well. If you hadn't seen the TDPs before from AMD and Intel, then you've seen them now. So this is exactly why it's so difficult to do accurate cooler testing, and this is why we never say that our tests are perfectly accurate. What you really want, just to have to address how testing looks from a reviewer standpoint, what you really want as a reviewer is to have perfectly inaccurate tests. So as long as your measurements are imprecise precisely, then you're good, by which I mean if you're always off by plus or minus 2 degrees, that's fine. It's when you have extreme variance that it's totally useless as a result. And so we have some plus or minus numbers on the bottom of our charts. If you're ever curious what the variance is and if a difference is significant, you can look at that plus or minus. So it says plus or minus 1 degrees Celsius, and you see two coolers that are 2 degrees apart. They're basically the same statistically. We don't have the test resolution to see a difference. Now, something like this, you might be able to start seeing a difference, of course, but I think that that addresses the cooler testing side. On the TDP side, these machines could also be used for determining TDP. So the test equipment, if you wanted to put a TDP number on the side of your box, just like this is used to put a CFM number on the side of the box, you could do that through here, just like we showed the hot plate over there with the cooler. You could theoretically produce a TDP number, but everyone uses TDP in different ways. So Intel's TDP is different from how AMD calculates theirs, and I forget exactly what AMD's is, but it's based on like an optimal processor temperature of 60.8 degrees Celsius and based on some ambient conditions, and there's a lot of stuff involved to create this formula to make TDP, so it's not necessarily comparable from one to the next. And then you also have issues where if a company making coolers puts on their box that it can support 150 watt TDP, and you have a processor that says it's 150 watt TDP, those might not be the same thing. So that's important to note as well. So these could be used to produce a TDP number, but I believe for the fans we were looking at, the coolers we were looking at, there's actually not a TDP number on the box, which is potentially the better way to go, just because otherwise everyone gets confused and no one really knows what TDP means. So that's it for this one. Thank you for watching. As always, subscribe for more. You can go to patreon.com/gamersnexus to support our tours and our lab visits like this one, or store.gamersnexus.net if you want to pick up a shirt like the one I'm wearing, but not literally this one. I've been sweating in it all day. So thank you for watching. I'll see you all next time.